Hello, Algebra 2. Chapter 5.6 goes over a topic that I know was taught to some of you in Algebra 1, but not to all of you. It's the quadratic formula. You'll remember a couple of weeks ago now I gave you a document, a double-sided document, and on the back side it talked about a progression of different types of techniques you could use to solve quadratic equations. And if you worked your way all the way to the bottom, you eventually come to the quadratic formula. And in fact, the quadratic formula is grouped together with two other ideas that we haven't yet touched on yet, both about completing the square in one case where a is 1 and the other where a is not 1. Don't worry, we'll get to that probably in the next lesson, but let's talk first about the quadratic formula. All three of these ideas have a very similar description on the bottom right corner of that page, saying that they're not useful when you're trying to factor, that they're only useful when you're trying to solve. In other words, when you have an equation. There's one other thing it says, use it when none of the other techniques work. The quadratic formula, and later you'll learn about completing the square, these are last resort scenarios, but they're very useful scenarios. The one distinct thing about the quadratic formula, and I've highlighted that in green here, is that you have to use it on with equations that are set equal to 0. So we'll talk about that in this video. So let's look at the specifics of what the textbook says about the quadratic formula. As I say, it's got to be an equation set equal to 0. More specifically, it has to be an equation that's written in standard form. You can't use this with an equation that's written in vertex form or intercept form. So make sure that you are comfortable converting equations to standard form. We talked before about the fact that that's a skill that ultimately will become necessary. Well, this is that time. You do have to be able to convert to standard form sometimes. Okay, so here is that quadratic formula without further ado. X equals negative b plus or minus the square root of all of this stuff, b squared minus 4ac. And this whole thing, including the negative b, is all divided by 2a. Now some teachers say opposite of b rather than negative b. Whichever of those two ways they say it, doesn't really matter to me. The crucial thing is that you memorize this basic concept. So in fact, on my website, I've got links to a number of different songs that are out there on YouTube that help you to memorize this equation. I'm not saying that any of them is better than any others. In fact, if you go to YouTube and just type in quadratic formula song, you'll be amazed at how many different people have made up their own custom songs to this formula. But it is something that you're going to have to memorize. In addition to that, those videos that help you to memorize it, I've also got on my website a guide for the quadratic formula. So in this video, part of what I'm going to do is walk you through that guide. Let's say you've been given this equation. Step 1, as I say, is to put it in standard form. The quadratic formula, after all, only works if it's in standard form equal to 0. So you move the 14 over. Step 2, you find a, b, and c. Well, a in this case is 1 on the x squared term and negative 5 for b and negative 14 on the third term. Now you plug those into that quadratic formula that I just told you you had to know. So let's say you've memorized that and you plug those values in as so. Hit the pause button if you like and make sure you understand how I've plugged these values into this equation to come up with this equation. Okay, I'm going to assume that you did that. Moving on to step 4, well, here's that equation that we'd had. So step 4 is to start simplifying what's under the radical sign. Negative 5 squared becomes positive 25. Please notice, this was negative b squared. I'm sorry, this was b squared, but b happened to be a negative number. It doesn't matter whether b is a positive or negative number. B squared is always going to turn out to be positive. This number here will always be positive, never negative. It's this part over here, minus 4ac, that sometimes is negative, sometimes positive. In this case, it's plus 56. Okay, so you keep going from this point forward. You simplify. 56 and 25 together make 81. You simplify further. You know the square root of 81. You know that's 9. So now I've got negative 5 plus or minus 9 over 2, and I can go even farther. Negative 5 plus 9. Well, after all, that's 4, so that'd be 4 over 2. Negative 5 minus 9 would be negative 14. So you're going to have x is either negative 7 or 2. The key point about the quadratic formula is it always works. As long as you can get a quadratic into standard form and set it equal to 0, it will always give you the values for x, help you to solve for x, where other of the techniques like factoring don't always work. So it's a great last resort to have. It's just, this is a long, slow slog to work your way through this to get to that answer. That's why we leave it till the very end, hoping that other techniques will work better. Okay, a couple of things that the textbook points out. First of all, they say, notice that what happens when you change the value of the c, the constant in standard form, that it can move the graph around vertically. And more specifically, it can move the graph vertically to the point where the parabola never actually touches the x-axis. So this top one here in blue with the largest c value, plus 10, that never actually touches. The red one, by contrast, where c is 9, just touches at one point. So there's only one solution for this parabola. There's only one x value and y is 0. The green one has two solutions. It has two intercepts. And it's not so different in c value from the first one, 8 versus 10. So the point that they're making here is that this c value can have a dramatic impact on how many results you end up getting. There's another way of thinking of it, and this is the way I tend to think of it. Look at it this way. I said this is always going to be positive, but this could be positive or negative. It happened to be positive 56 in this case. Let's say it had been negative 56. Then this would have been a negative square root. Remember, negative square roots are imaginary. And remember, imaginary numbers can't be graphed. So this blue parabola here has two imaginary solutions to y is equal to 0. It doesn't have any real or graphable solutions. It's also possible that this number here, which turned out to be 25, this could have matched it. It could have been minus 25, in which case this would have been the square root of 0. When that happens, you only get one result, 1, 0, as it said. Okay, and this is in fact exactly what the textbook is saying on this page. They're calling this concept, this idea of the information below the radical sign, the discriminant. It's b squared minus 4ac. And their point is, you can use that to decide how many solutions you're going to get. It can be used as a quick check so that you don't have to do quite as much work only to find out that you weren't going to get any solutions after all. If b squared minus 4ac is more than 0, then you will have two real solutions. If the two cancel each other out, in other words, if b squared is the same amount as minus 4ac and they turn out to be 0, then you're going to have one solution. And if the 4ac is in absolute value terms larger than b squared, if this is negative and larger, so in other words b squared minus 4ac becomes something below 0, then you're going to have those two imaginary solutions that I talked about. The guide that I've got on my website also talks about the discriminant. It works this through. So step 1 here is to put this example in standard form. I move all the pieces on the same side. I end up with negative 3x squared minus 2x plus 11 is equal to 0. Once again, I find a, b, and c. There they are. This time I only applied the discriminant formula. Let's go back and remind ourselves. The discriminant is the portion of the total quadratic formula that's under the radical sign, b squared minus 4ac. So that's what I'm looking for here, b squared minus 4ac. And I plug these values into this formula, and I come out with the conclusion 136. So the discriminant is 136, and oops, didn't mean to select that. As this says, if the discriminant is more than 0, you've got two real solutions. Well, the discriminant was 136, so I will have two real solutions, and I'm going to go ahead and solve the equation using the quadratic formula and expect to find two different x-intercepts. If it had been equal to 0, I would have had one solution. If it had been less than 0, then I would have had I in my answers, and I would have had two imaginary solutions. Now, let's put this to use if we do have two imaginary solutions. First of all, I'm going to have to get this in standard form, as I do here now. Then I'm going to have to figure out what a, b, and c are and plug them into the quadratic formula, as I have here. And then I'm going to go ahead and simplify and solve. And as you can see here, I'm going to end up, because I've got the square root of -4, I'm going to have 2i there, plus or minus 2i, as that says. Or simplifying down, I'm going to end up with x equals 1 plus or minus I. And if I graphed that, it would be a parabola that never actually touches the x-axis. Okay, so now I want you to do some of the work. So go ahead and answer 11 and 12. In those cases, you're supposed to simply find the discriminant and tell how many solutions, how many real solutions your equation should have. And then for 24 and 25, after putting the equations in standard form, I want you to go ahead and use the full quadratic formula and solve those two equations. When you come back, I'll show you the answers to all four of those questions. Okay, I'm going to assume that you've at least done 11 and 12. So here, to get anywhere with question 11, you had to put it in standard form. So here is 11 rewritten in standard form. Now that you've done that, b squared minus 4ac turns out to be this. And then if you work that out, you're going to find that you're going to end up with the answer 37, which is a positive number. And so therefore, you've got two real solutions. For number 12, worked all the way through in similar fashion to number 11, you're going to find that the answer is 9, again a positive. So therefore, again, you're going to have two real solutions if you apply the quadratic formula to that equation. Hit the pause button and make sure you have the same answers and understand the answers for 11 and 12. If you don't, come in and ask questions. I'm going to go on at this point to 24 and 25. So again, if you haven't done 24 and 25 yet, pause, work them out yourself, and then I'll show you the answers. Okay, beginning with 24, like before, you have to get this equation into standard form to get anywhere. Well, here is 24 rewritten in standard form. Now you plug a, b, and c, you plug a, b, and c into the quadratic formula. You should set it up like so. And if you work the quadratic formula out, you're going to find that you're going to end up with -3 plus or minus the square root of 41 over 8. You can't simplify the square root of 41 any further down, so this is as far as you can go in answering 24. For 25, similar story, you end up with a fairly complicated looking answer like this, 15 plus or minus the square root of 89 over 4. And you got there once again by turning the equation that you were given into a standard form equation, and here is that standard form equation, and then applying the quadratic formula. So that's everything that I wanted to teach you in the lesson for the quadratic formula, except for one other thing. I forgot about example 5. We talked before, back in chapter 5.3, about the formula for a falling object, and said that this was the formula for how fast an object falls. When it's dropped, though. Now, what about if it's thrown? In that case, you have to add an extra term. You have to multiply time times the initial velocity when you throw the object. So, for example, this word problem here, and hit the pause button, read this and make sure you understand the word problem. But this is indicating that there's an initial velocity to this baton that's thrown up into the air. So now the equation is going to be that same familiar -16t squared plus the original height, but in between those two terms is the initial velocity of the baton times t. So you plug those values in. Initial velocity of the baton is 45 times t. It goes into what had been up until now a familiar looking formula. So you're going to catch it at height 5 feet. So you've got to rewrite this formula so that it's equal to 0 by moving the 5 over. Now you can apply the quadratic formula. You go ahead and apply that quadratic formula, and you're going to find the time is this fairly complicated looking answer. But fortunately, with a calculator, you can find that the time, well, the positive time, the one that makes sense, is 2.8 seconds. And that's about how long the baton is in the air. Don't hesitate to come in with questions if you didn't understand that, and there's your homework.